Today, the topic of my discussion is muscle relaxants. What actually are muscle relaxants? The drugs which are used for relaxing the muscles are known as muscle relaxants. As we are already done with antimuscarinic drugs, now we will be focusing on anti-nicotinic drugs. So the receptors here will be nicotinic acetylcholine receptors. There are two major groups. One is neuromuscular blockers and the other one is spasmolytics. In this section, we will majorly be focusing on neuromuscular blockers. Before proceeding to our main topic, one must know what is the origin of a drug we are studying, what is its history, from fun hunting in jungle to Operation Theatre. Basically, the origin of a neuromuscular blockers, the muscle relaxant, is from a plant named is Condodendron tomestosum. The extract of that plant is named is curare. The term curare came from the arrow poison urare. The story was like the South American hunters used to dip the tip of their arrows into that extract and use that arrow for hunting. What they find out is that animal gets paralyzed after being hit. At that point, they get to know that this extract is having some neuromuscular properties. So what is a prototype drug here? It's tubercularine, a naturally occurring alkaloid, constitutes the active component of curare. Its structural analog of acetylcholine. Its structure is shown. Introduction of neuromuscular blockers. What actually are neuromuscular blockers? As we already know, we are studying them under the category of muscle relaxants. So they are muscle relaxant. But which type of muscle relaxant? They are actually skeletal muscle relaxant. They are targeting the skeletal muscles. What they actually do, they block the cholinergic transmission between motor nerve ending of a neuron and a nicotinic receptor which is located on a skeletal muscle. When they block the transmission between these two endings, these two main points, that will be known as a neuromuscular block, and the junction between these 2 points is known as neuromuscular junction. So we have to block the events going on neuromuscular junction. This is the diagram of a neuromuscular junction. You can see there is a neuron which is coming, and there is beneath there is a muscle, a skeletal muscle, a striated muscle, and the junction between them is known as neuromuscular junction. So we have to stop all the exchange occurring between this junction. Either there is acetylcholine release, either there is opening of the sodium channels. Whatever the event is happening, we can stop any step of these events so we can achieve our target. Neuromuscular blockers differ from each other in mechanism of action, duration of action, speed of onset and offset of action, selectivity of the action, and safety margin. Every drug has its own safety margin. Adverse effects. A drug is never without an adverse effect. So these were the few characteristics which we studied in the previous slides. Those characteristics of neuromuscular blockers are giving us a way to classify the neuromuscular blockers into different categories, because they are differing in these certain characteristics. So we classify them according to 3 main categories. The first classification is classification according to their mechanism of action. So how we can classify according to their mechanism of action? There are 2 major mechanisms of action which are happening in neuromuscular blockers. The first category is non-depolarizing drugs, also known as competitive antagonists. This means these are the drugs which are competitively fighting for the receptor site, and they competitively bind there. And non-depolarizing means they will not depolarize the membrane. There will be no action potential, there will be no depolarization, because they are competing for the site, and they will not allow acetylcholine to bind to that site, and there will be no depolarization, there will be no opening up of the sodium channels, and there will be no contraction. So non-depolarizing, competitively fighting for the receptor and making the membrane not to depolarize. So its name is suggesting all about its mechanism of action. The second category is depolarizing drugs. This means that these drugs are those drugs which are making the membrane to depolarize. There will be an action potential. They're non-competitive but acting as a agonist. So means these are the drugs which are acting as an agonist of acetylcholine receptors, nicotinic receptors. So they go there, they act as an agonist, they depolarize the membrane, but there are certain events, there are certain differences between the depolarizing drugs and acetylcholine. Although they are the structural analogs of each other, but there are certain differences which we will discuss later on, which will make the difference and how they will affect and how they will paralyze or relax the muscle. The second category is classification according to chemical structure. So there are so many members of each category, each group. So every member is different in their chemical structure. So these are the bases. These are giving us the basis for classifying them according to their chemical structure. In case of depolarizing drugs, non-competitive, acting as agonist drugs, there are not much members. There is succinylcholine and decamethonium majorly. So they are quaternary ammonium ions. So we do not need them to classify further. But in case of non-depolarizing drugs, which are competitive drugs, there are many members of the group, so we classify them according to their structure into three subcategories. Let's see what are those. This is the structure of the succinylcholine, a depolarizing drugs, which is a quaternary ammonium ion. Non-depolarizing drugs, these are further subdivided into three subcategories according to their chemical structure. The first one is steroid, the second one is isoquinolone, and the third one is miscellaneous group. So you can see the first subcategory is steroid, and the members of this group are vicuronium, rocuronium, pancuronium, papicuronium, and rapacuronium. So these are the non-depolarizing drugs. These are the neuromuscular blockers which are steroid in nature. The other category is isoquinolones. So the competitive type is having second subcategory according to its structure is isoquinolones, and the members of its group is tubocurarine, metacurine, mivacurium, atracurium, doxacurium, and cisatracurium. And the third one is miscellaneous group, and the member of this group is scalamine. So far we have classified according to two main characteristics. One was its mechanism of action, and the second one was its according to its chemical structure. According to its mechanism of action, there are two types. One was depolarizing, also known as non-competitive, acting as an agonist, and the other one was non-depolarizing, competitive antagonist. And according to their structures, in the depolarizing category, they were quaternary ammonium ions, and in competitive antagonists, we are further dividing them into three subcategories. Those are steroids, isoquinolones, and miscellaneous groups. Let's see what's the next characteristics which are giving us a clue about their next classification. So the classification according to duration of action. So This category of classification is based on how long they will act, duration of action. So duration of action can be short acting, intermediate acting, or long acting. So we have make a certain criteria, and the criteria is if the duration is less than 20 minutes, that will be considered as short acting, and if the duration of action is between 20 to 30 minutes, it will be intermediate acting, and if the duration of action is more than 30 to 35 minutes, it's considered as long acting. So the short acting category is having mivacurium, succinylcholine, also known as succinylcholine, rapacurium. This classification is also giving us a clue that if we are introducing this neuromuscular blocking agent, so what will be its duration of action, what can be its dose, how long it will be effective in the body. So which surgeries are suitable for using this certain type of neuromuscular blockers. The second category is intermediate acting, ranging from 20 to 30 minutes. Its duration of action is for 20 to 30 minutes, and the members of this group are atracurium, rocuronium, vicuronium. And the next we will see the third type, long acting more than 35 minutes, and the members of this group are tuberculin, metocurine, toxicurium, pancuronium, pipacurium, galamine, and cis-atracurium. These are the long-acting drugs. So we are done with the classification. We have classified the neuromuscular blockers according to their mechanism of action, according to their chemical structure, according to their duration of action. As galamine is used quite extensively in surgical procedures along with other anesthetic agents, so let's quickly go through it. It is non-depolarizing neuromuscular agent that competitively blocks acetylcholine, as we have already studied galamine under the classification of competitive antagonists. It's used along with other anesthetic agents for muscle relaxation. Its structure is shown